Okay, I think we can start. So, hello everyone and good afternoon. And I'm very happy to welcome you. I'm Pnina Sofer, and together with Andy Rivkin, we both chair this session of a BPM forum devoted to modeling. And we have 5 interesting and stimulating papers, and you will see each one for about 10 to 12 minutes of presentation, and then we'll have some time for questions. So the first paper is a paper from Vienna. It will be presented by Bastian Wurm, and it's also authored by Jan Mendling, and it is about theoretical model for business process standardization. So Bastian, please.
Thank you very much, Pina, for this nice introduction. And hello, everybody. My name is Bastian Wurm. I'm a PhD student at the Vienna University of Economics and Business. And in the next couple of minutes, I will talk about a theoretical model that we developed for business process standardization. First of all, our definition for process standardization is basically based on a definition by Münstermann and Weitzel, who define standardization as the activity of aligning different process variants against a standard process or a meta process. So that's essentially reducing the variation in the different processes your operation or your organization operates. Furthermore, it's important to differentiate between the process of doing that, so actively process standardizing a process, and the outcomes of really achieving a standard or homogenized process. In that sense, we also view standardization and harmonization basically in a similar perspective because both aim at reducing variation in business processes. Prior research has mainly focused on the outcomes of business process standardization, for example, cycle time, cost, or quality. However, there's little knowledge about antecedents and contextual factors that influence process standardization, and that's what we want to address basically in this piece of work. In that sense, our work is based on the socio-technical systems model by Bostorff and Heinen. In 1977, when they introduced the model, they argued that a lot of software development projects were failing because the development process was either focused on the social system or on the technical system, but failed to infiltrate both perspectives. So what they say is basically that when we face information technology, we have structure, we have people that execute different tasks, and we have technology that supports people in executing their tasks and the people that have assigned different structures or basically are assigned different roles. And in that sense, a business process is a form of a social technical system, as has been also highlighted, for example, by Alter. And a business process is then again part of a larger social technical system. In process standardization, much work has focused on the execution of a process, on what is that, so like how is a process executed when it's standardized, but contextual factors have been neglected. So the research question we set out to answer was, what are antecedents of business process standardization? And we answered or addressed this research question using a structured literature review as outlined by Kitchenham, where we used the search terms process harmony or process standardization and searched 4 different databases leading to roughly 250 publications. Furthermore, we carried out expert interviews. So we carried out semi-structured in-depth interviews with process experts from a multinational enterprise. For example, we interviewed the head of process excellence and IT governance, release manager, a local coordinator for processes, the head of HR management processes, and also global process manager. So we did that in order to complement basically our literature review and gain a little bit more practical also insights into what was important and relevant for them when standardizing their business processes. So the outcome of this endeavor is depicted on this slide, our theoretical model for process standardization. And basically we derived a set of different propositions that are well discussed in the paper and highlighted here. So first of all, business process standardization is a matter of strategic importance and strategic focus. So whether your company is oriented towards exploitation of existing business processes or exploration of new business processes, so rather more innovative. That influences the type of governance mechanisms that are implemented. So for example, in companies that have a focus on basically on lean management and more on, well, in terms of scale, they would implement, for example, process audits to monitor that business processes are executed in a certain way. Also, in those types of companies, then business processes are usually very formalized, and there's rigorous documentation and training for employees to make sure that business processes are basically executed in a certain way. Also, information technology in those companies is way more leading than it is for companies where processes are rather unstructured. Also because it's very difficult for some of those processes to be ex ante actually prescribed. And that leads then actually, so those factors lead then finally to how the business process is executed, whether that's done in a consistent way all over the organization or whether that varies to a considerable extent in the different, basically in the different subsidiaries. Additionally to that, we identified, so for reasons of time, I will not go too much into detail here, but additional to that, we identified 3 contextual factors that basically mediate those different effects on one another. So for example, knowledge intensity. When I have a very knowledge intensive process, usually what happens is that my information technology can be way less leading. So for example, in healthcare, every process is different, every patient is different, and that's why information technology is not very much leading, but provides a lot of freedom basically for the knowledge workers to basically execute their task in the best way. As a conclusion, our contribution is a theoretical model that integrates the literature on business process standardization, and we explain the different antecedents and also contextual factors that affect business process standardization, and we made them explicit by our model by proposing the different propositions in our model. For future research could look into the empirical validation and to really test the model. There are measurement scales out there to measure those different constructs and really to validate to what extent the relationships are in fact true. But we also highlight that other methods can be used. So for example, process mining can be used as a method to see to what extent different processes vary and also under what circumstances, so in what context basically business processes vary and also how that changes, for example, over time. So with that, I would like to open the stage for feedback and questions if you have any. Thank you.
Thank you very much. That was very interesting. We're now open for questions from the audience. Any questions?
Please feel free to write them in the questions and answers box or raise your hand. So far there is nothing, but Nina, do you have questions here?
Yeah, I can start.
Yes, please.
The first one. So just about terminology or perhaps semantics of this notion of standardization. Can you tell me in what way it is different from rigidity?
From rigidity? Yeah. Well, I would say standardization, rigidity, I would say is a normative term that says, well, something is rigid or it's flexible, right? Mm-hmm. Standardization, I would say, is way more neutral in the description. However, probably much about what you would understand as being rigid is maybe also viewed by other people as a standard process. Yeah? So for example, a standard process is usually executed in the same way. You could now argue that this is rigidity, But
it's in the eyes of the beholder, isn't it?
Yes, I would say so. And I mean, it also depends whether when you have external triggers or external kind of shocks that impact your business process, whether you then remain the same and you remain rigid, or whether you then actually can change. Yeah. So I think that's the key question that also differentiates standardization from rigidity, because rigidity would apply that I cannot adjust, but standardization just means, okay, at the moment we're executing that in a consistent manner without having the judgment whether this is good or bad.
Mm-hmm. Good, thanks. Any other questions, guys? One at a time, please. Andy, do you have any question?
Yes, I actually do, but it's rather so. I'm not very much familiar with the standardization part, and I actually, thanks to your presentation, I start seeing the value in having, you know, this sort of the roadmap that one would follow when developing very complex processes. But there is the part about knowledge intensity that. So I actually probably would like to hear more details about the knowledge intensity. What do you mean exactly by knowledge? Do you mean the knowledge that is the knowledge that probably people talk about when dealing with DMN tables, right? So you have some kind of knowledge that is stored in the enterprise and you need to work with it, or it's some other knowledge like data that constantly comes and goes and changes and can affect a lot the process. Because you see, somehow knowledge intensity means that you have some kind of rigid corpus of knowledge that you can always call for and base and reason based on it. Whereas there is data part that is, let's say, more dynamic.
So first of all, thank you for your compliment and for the question. I think that that is a very important aspect. So with knowledge intensity, we basically understand, well, there's jobs that require very few knowledge, or knowledge that can be easily basically explicated. Yeah, like for example, I make a rule for how a certain task is to be executed. Yeah, that would be, for example, like a lot in tasks that we have, for example, under Taylorism. But there's also tasks or jobs that can not be formalized and cannot pre-describe ex ante because they require a lot of knowledge in their execution. So, and that knowledge does not mean is necessarily domain tables or necessarily data, but a lot of this knowledge cannot even be explicated. Yeah. So, for example, a doctor who does a treatment on, for example, well, some form maybe of skin cancer or something like this, and adapts this treatment to the patient, this knowledge is very hard to formalize, right? Maybe there's some rules of thumb the doctor applies, but in essence, they have been going through like very years of training to basically make sense of all the data or like information they get from the patients. So that means where it's hard to put the knowledge you need to execute the process into basically words or descriptions. Those kind of, and you need to rely a lot of on your personal judgment, essentially. Those kind of business processes, they're very hard to formalize. So there's often few documentation on that process. And on the other hand side, for those processes, information technology cannot be that much leading because the system cannot be described in its completeness, right? And that's why, yeah, basically that's how then knowledge intensity influences formalization and information technology.
Right. Thank you very much for this answer. Actually, we have one question. I think we have 1 minute. I'll read it. So it's from anonymous attendee. What's the value of this model for practitioners who are standardizing their processes?
Well, so exactly that's what we're targeting here, and that's what we had in mind to provide something that is kind of a roadmap for practitioners that they can think about. They can think about what is my strategic focus actually, like, do I aim even to standardize my processes, and what do I target on as an overall organization? And then also, what characteristics does my process have? Is it knowledge intensive? Do I have different legal requirements I need to follow? Are there cultural differences that may matter? So all of this you can take into account and by that kind of like basically follow this model from left to right to think through to what extent process standardization is valuable for a company, and also to what it can be even implemented.
Thank you very much for this. Yes, I think we're out of time, right?
Yes, we are. So now we need to see the next presentation. Can you please share your screen? Yeah, so the next talk is about cross-case data objects in business processes, and it will be presented by Stefan Harman, and it's a work done with Matthias Weske. So please, Stefan.
Thank you, Pnina, for the nice introduction. I hope you can all hear me clear and loud and see my slides. Like already introduced, I will talk about cross-case data objects in business processes. And first, I would like to take a step back and talk about data in business processes in general. So when we look at data, okay, no, it works. So we use data for many different processes, for many different purposes when we model processes. One, maybe the most prominent one, is for decisions when we have branching in our control flow and show the conditional execution of activities. But we also can use it to represent indirect dependencies between different parts of the process. And these can even be concurrent and then express synchronization. And finally, but also very important, we use it on an implementation level. And we want to depict what data is required or updated by an activity automatically or through user input. And in common business process modeling languages, such as BPM, we have elements to support this. We can have activities that create data objects. Here, for example, we have the activity find accommodation, writing the data object accommodation in state selected. These objects can then be read by activities, in this example, book accommodation, or we may have activities that do both. They read the data object and then write it again, thereby updating it. So in this activity, distribute goods, reads the goods in state received and updates their state so far afterwards it's in state distributed. Also in these modeling languages, we have some rather strong assumptions about the data that is involved. One of these assumptions is that data is usually not shared among processes, and another assumption is that data objects are usually not deleted within one process instance. However, there are some exceptions. You're probably all familiar with these elements that I show here. We have the input and output data objects that allow us to inject data into a process instance and persist the data object after the process instance terminates. We have data store to represent general persistent data, and we have message objects to represent data that is shared between process instances of different organizations through communication. And this already shows that there is a need for actually having persistent or shared data in processes. And the fact is that in many implementations, we simply have a database that can be accessed by the different process instances, most often even concurrently. And from now on, I will refer to this kind of data that is available to different process instances at the same point in time as cross-case data. So when we look at an example here, we have two different processes. Very simple ones, just for illustration. On the top, we see the process of ordering stationeries for our office. We have a request, we order the goods, and then we receive and pay the goods. And finally, we distribute the goods to those who need them. And the payment activity, that's the one that we are interested in. Because here we access a global, a persistent object, the budget. And we may even change its state, so if it is available before, it may be depleted afterwards. Now we have a second process, in this case, booking a business trip. And here we have a similar progression. We find an accommodation, choose a flight, and then we book our travel. And again, we access the budget object and may deplete it in that case. And you already see these processes that in theory or previously have been considered isolated from one another are not in fact isolated. Even instances of the same process may be connected through these shared data objects. And this can lead to different scenarios. First of all, if we have these shared data objects, the process kind of has global requirements posing on these objects. For example, when we order office supplies, we need budget to do so. If all our budget is depleted, we cannot do that. Since we have different processes and process instances accessing the budget objects, we may have deadlocks caused by other processes. But we can also have the inverse fact, where we have a process like allocating additional budget that unstucks kind of our other process instances and really resolves our deadlock. And I think this shows it quite clearly that it is insufficient to look at single process instances when we model processes, when we execute them, when we analyze them, even when we mine them, like it has already been shown in many previous works. So we thought, how can we capture those interconnected process instances with some of the peculiarities of this cross-case data access? And to this end, we propose CPN-based semantics. So first, let me introduce the color sets, the types of tokens that we use. We have a control flow token and we have data object tokens. These data object tokens are further distinguished into cross-case data objects and into case-specific data objects. The case-specific data objects have, besides an ID and a state, also a reference to the case, which is also referenced by the control flow. With these mappings, we can now assemble the process structure. We used hierarchical Petri-nets for comprehension. And first, we have a high-level representation that just shows the structure of the process. So similar to before, we have our different activities now represented as single transitions. We have gateways, our start event, and we have places for the different data objects, typed as case-specific data objects or as cross-case data objects. Now, if we zoom into one of those transitions, we find a subnet. So let's look at the book travel transition. Here we have one of the variants where we read an available budget and write it back in state depleted. First, we consume all the objects that are required and the control flow token. Through pattern matching, we can make sure that the case-specific data objects belong to that specific case. Furthermore, that the state matches. Then we access the budget object as well and write back the tokens in the respective state. So for example, here depleted. And furthermore, we create new objects. In this case, we create a case-specific object that receives a new ID, but still refers to our case ID. By doing this for the whole process, we get a formalization for the process model, including the cross-case data objects. By merging the formalizations of different processes through the budget object, through the budget place, we can connect these processes and simulate or represent the interdependencies between the process instances. There is a second variant of the book travel activity where the budget remains available, and this one is mapped analogously. So far we can access any of the globally available data objects. But it becomes interesting if multiple of them are available, but only certain fit our case.
Stefan, sorry, you have 1 minute left. Okay?
1 minute left. Okay, thank you. To this end, we propose two different methods. So on the one hand, we may have key-based correlation, where we have a simple predicate to decide which global objects fit. And also we have case-based correlation, where we say objects should be allocated consistently. By adding this information, we can now use our CPN formalization to, for example, verify our processes, for example, the case soundness of it. So to sum it up, processes access data. They create new data objects, they read them and update them. An assumption often taken in data modeling and execution is that data is local to a case, but this rarely holds because we have globally accessible data objects. And this requires some need to know about the dependencies between data instances And for this, we propose CPN-based semantics that can be used for both specification and verification. This concludes my presentation, a little bit over time, but now I'm open for questions. Thank you.
Thank you very much. Any questions from the audience?
We actually have one already from Paul. So maybe I could unmute you and you ask it personal, okay? So let's see if it works.
It works, I think. Thank you. That is, if you can hear me.
Yes, we can hear you.
Yes, my question is actually quite simple. As someone who has worked in transaction management for actually for a long time, aren't you simply reinventing transaction management in business process management? Since transaction management is actually meant to regulate concurrent access to shared data. There is a substantial amount of work on this already, quite old actually.
Yes, I completely agree. So that transaction management is a part of what we now present, but I would say that we look at it on a different level of abstraction. So we do not look at how transaction management is kind of dealt with or what is done in transaction management. For now, we assume that every activity is a transaction, atomic read-write operation, so to say. And we, under this assumption, we only show how the different processes or process instances are connected through data. How these transactions are actually managed, that is part of transaction management. And on a higher level, I agree that then again, we might want to have bigger areas of transactions, giving priorities or anything like similar things. But we don't deal with that here. We just show the connection from a process point of view. So if we have those transactions, where are errors that could occur in the process flow?
Okay, but I still think if you look at existing work, there is multi-level transaction management that goes actually from low-level transactions, which are more, say, database-oriented,
yes,
to high-level transactions, which actually take process semantics into consideration. So I would strongly urge you to look at this existing work. I think there might be more overlap than you see right now.
Okay, thank you.
If you want some links, just send me an email and I'll send you some references.
Yeah.
You're welcome.
Thank you.
Any more questions?
There was a question by Jan.
Yeah, please.
Sorry, Pina. I don't know, we had a concurrency issue. So there is a philosophical question by Jan. How does the type instance property work for the budget object?
The type instance property object.
Maybe I could unmute Jan.
Yeah,
so
maybe you can elaborate on that.
Jan? Okay, Jan is not
responding.
No, yes.
Or do you hear me?
Yes, now yes.
All right, good. So, well, you referred at different stages about objects and their objects and instances of particular classes.
Yes.
I wonder in how far actually that works for the budget. I don't know. You want to call it object or class here in this particular setting, because well, you don't have different budget instances that you're dealing with here, right?
So we distinguish between different budgets. Even the cross-case data object, it has an ID. So in theory, we can model it through different tokens. And as I mentioned briefly when I was running out of time, we propose different methods and have CPN formalizations for how to choose the budget object that fits a certain case. So similar to when we map events to processes, we may have key-based correlation, where we say that that we have some predicate that is evaluated on the process data and the cross-case data to find fitting budget objects. And we also have other properties, for example, the case-based correlation, which is similar to case-based resource allocation, where we say, okay, once we access a certain budget object in a process instance, this instance must stick to this budget object. So it's kind of
but that is the budget object, but that is not a budget amount, or that was actually that kept me thinking.
Okay, yeah, we do not model attribute level information here.
Yeah.
If there would be multiple budgets and one would be in state depleted and the other one would be in state available, this would be a mapping that would be anyway done, so if only the available ones could be consumed. But to formalize it on an implementation detail, we would need to incorporate the actual attributes, which is not done at this point.
Right. So it's more or less that I can think of this here as different accounts, let's say.
Yes.
Okay, good. Yeah, that was not fully clear to me. Thanks a lot.
Okay.
Okay, so I think we are running out of time now. So maybe we...
Yes, so please, we can move to the next presentation.
Yes, so I hope you can hear and see me.
Yes, yes. So this is Konrad Schneid talking, and he will be presenting a paper about future development in BPM-based process-driven applications. And now you can speak.
Okay, so first of all, thank you for the great presentation so far. I really enjoyed them. My name is Konrad Schneid and I'm from the University of Applied Sciences, Münster, Germany. And I'm very happy to present today our paper about feature development in BPMN-based process-driven applications in the context of continuous software engineering. Before I start with the presentation of our concept, I would like to clarify the terms process-driven application and continuous integration and point out the current research gap. As you probably know, process-driven applications play an essential role in the IT environment of enterprise solutions and are used to automate the execution of business processes. As you can see on the left side, process-driven applications are implemented not only by source code, but also on executable process models, such as in BPMN or DMN. To run a process-driven application with these artifacts, a process engine, such as the open source product Camunda BPM, is necessary. The engine runs, as in this example, as a separate service interacting with the user interface, for example, for human task, the implemented process applications, or external services. Continuous integration is an established best practice of software development. The main idea is to keep all artifacts, so in case of process-driven application, especially the process model and the source code, in one single repository. The developer have to commit their changes continuously. And through the commit, an automated pipeline is triggered, which runs several jobs, such as building, testing, and analyzing of the deployment artifacts. Afterwards, the developer receives immediate feedback on his committed changes. If all tests are passed successfully, the result is a deployable build. The continuous delivery approach goes even one step further and includes, as a final step, deploying the application to a target environment. Due to the high degree of automation, it is possible to keep feedback loops and release intervals short, whereby the test coverage and code quality is high. The question we have considered is how new features can be developed for process-driven applications in the context of continuous integration. Continuous integration, as just explained, implies committing changes regularly. This means at least at the end of a business day. The question is how to deal with implementation of new features that are still under development and not yet ready for release. For source code, there are already approaches. The software engineering committee mainly distinguishes between develop and mainline and branch by a feature. Following the branch by feature approach, a separate branch is created to commit the unfinished work, so the mainline will not be disturbed by this unfinished feature. As soon as the development in the feature branch is complete, the new feature will be merged into the mainline. But due to the missing of the permanent integration, this approach contradicts the continuous integration idea. Following the develop on mainline approach, changes only take place directly on the mainline. So changes are immediately available for every developer involved, and the core idea of continuous integration is fulfilled. To handle unfinished code, concepts such as feature toggles can be used. This allows features to be activated and deactivated, and so features under development have no negative impact on release status. For the process model, as an important part of a process-driven application, such a concept is missing so far. That's why we have developed the Toggled for Process-Driven Applications, or T4PDA approach, which takes both the process model and the source code into account. Okay. Let me explain our idea. The concept consists of two essential steps when creating a new feature on process model level. Here we have a small example process of an online shop. We now want to change the area around send invoice and deliver goods, which is our so-called feature scope. In the first step, we encapsulate this feature scope in a collapsed subprocess, here called old implementation. This will not change the functionality so far, only the visualization. In the second step, this new subprocess is cloned. The two subprocesses, new and old implementation, are placed as an alternative path subsequent to a newly inserted XOR split, which evaluates a feature toggle. The upper original subprocess can be run for the time the feature is under development. The subprocess new implementation forms the workspace for the process designer. Once a development is complete, the old path and gateway can be removed. One important element is the inserted business rule task at the beginning of the process, which refers to a decision model in DMN notation. In this decision model takes the evaluation place which feature or toggle is currently active. So let's have a look at our decision model. This decision model can be used either locally or if certain functionalities affect several processes across the entry process landscape. The result of the evaluation of this decision model is a list of active features. One decision criteria in this example is the stage. So at the beginning, the new feature could be activated only at development stage. Another decision input in this example is the process instance initiator. But the list of decision inputs can be extended by any number for additional decision criteria, such as user groups. And due to its simple notation, the decision model can be managed by both programmer and process designer. The manual effort following the T4PDA approach is quite high. This is why we have developed tool support to follow this approach. In our case, we developed a plugin for the Camunda modular. The plugin has two functions, start feature and complete feature. The start feature function automatically performs the following task. If not yet available, a decision model is created. Afterwards, a toggle is added to the DM, which is deactivated by default for all criteria. The transformation is performed automated in the process model as previously described. If no business rule task was available up to now, this will be added as well. Furthermore, the toggle is added as a constant in a Java helper class. This should make it also easier for the programmer to use the toggle in his source code. The opposite way is performed with complete feature. In this case, the toggle is deleted from the DMN and Java helper class. In addition, the outdated path and gateway will be removed in the process model. For evaluation, we used an APBA crossover design experiment. 18 volunteer students registered for the experiment who are familiar with the development of process-driven applications. The participants were randomly divided into two groups. The first group applied T4PDA in the first round only, the second in the second round only. Therefore, we had different case studies in each round. A set of tasks, such as starting a new feature, completing, or discarding them later, had to be solved. The changes affected both the process model and the program code. Every time having fulfilled the next task, the participant had to commit their intermediate results to Git repositories provided beforehand. And every commit was triggered by a small continuous integration pipeline, which validated the artifacts and the correct solution of the task. It was not allowed for the participants to run local tests. The rate of successful builds with our approach is almost twice as high with the traditional approach. This indicates a higher software quality using T4PDA. Among other measurements, there was a survey of the experiment, and more than 88% of the participants preferred to use T4PDA in their future development. So to sum up, with T4PDA, we presented the first approach which enables feature development on mainland for process-driven applications. We have combined the strengths of process modeling with BPM and DMN with the strengths of software engineering techniques. We have involved all developers, so process designer and programmer of a process-driven application in this procedure. The process remains transparent for all participants, including the end users. Merging conflicts, as with feature branches, are avoided. And T4PDA also has some other nice side effects. For example, it enables canary releasing or supports A/B testing. Okay, that's it. You can download our Camunda plugin at the linked Git repository or read our paper for more details. And now feel free to ask any question. Thank you.
Thank you very much, Konrad. This was very interesting work. So are there already questions from the audience?
Nope. So far, there's nothing.
Okay.
Nina?
So yeah, so until there are more questions, I can ask a bit about the experiment. It's very interesting what you did. Can you tell us a bit about the case studies that you used and the assignment? How realistic were they, considering like real life development of processes?
Yeah, so in the first round, we had a very simple abstract process-driven application example, just a pizza delivery consisting of 6-7 BPM elements, just to that they get warm with the idea of continuous integration, combining with process-driven applications. But in the second round, we got a process-driven application from an industry partner, and so it was a realistic process, a large one. So I think the second one was quite realistic. Yeah.
Thanks. And there's a question from Ingo.
Hi. Can you hear me?
Yeah.
Great. Yeah, thanks for that. Quite interesting work, connecting also to DevOps, of course, and works in this space. So I see your path for adding feature toggles, but once you start down that path, which is of course a valid one, then you also get into issues like managing the feature toggles not only for the BPMS but also for the implementations of the tasks behind the BPMS, as well as having at some point probably a larger collection of features which you toggle on and off, and then it can be quite hard to keep an overview. And eventually, of course, you want to get to the point where you get rid of the feature toggles as well. Have you given much thought to that?
Yeah, so removing these toggles at the process model level is quite easy because there is technical support. Yeah, we have a complete feature function. More complicated is to remove toggles in the source code. Yeah, but we have, as I said here, a Java helper class where all these toggles are added as a constant. So, and when we remove the toggle in our process model, the constant of in the Java helper class is also removed. And thereby, the compiler informs you that the toggle constant is not longer available and you have to change your code. So because a big problem is that people forget about their toggles and they are still in their code without having any effects anymore. So the removement of these toggles is still a manual process at source code level.
Yeah, which was the sort of second question that I asked about the management of toggles, especially if you have more than that. And I agreed to your with your points that you raised about issues of people forgetting to take them out or struggling with doing that.
Okay.
Okay.
Okay, so the second question wasn't answered, but that's okay if you don't have time.
Yeah, I'm afraid we probably have to go on.
Sure.
So thanks, Ingo.
Okay, so we thank Conrad and we have to move to the next speaker now. Konstantin?
Yes.
Yes, okay. So the next speaker is Konstantinos Taraganos, and this is a team from Eindhoven. And the talk will be about dynamic process synchronization using BPMN 2.0 to support buffering and unbundling in manufacturing. Please.
Yes, hello, thank you. My name is Kostas Taraganos, and I will present you also on behalf of my colleagues our work on dynamic process synchronization using BPMN 2.0 to support buffering and unbundling in manufacturing. I'm a PhD researcher at the Technical University of Eindhoven, working on BPM and information systems in manufacturing, also involved in various European projects. First, I will introduce the background of our research, stating the problem we are trying to solve. I will then present the proposed solution, some implementation details, and finally conclude with a future work discussion. In the Industry 4.0 era, manufacturers face many challenges, such as safe human-robot collaboration, small batches of customized products, dynamic production scheduling due to changes, etc. The introduction of advanced technologies has helped them in automating their processes and getting more efficient. However, there is a lot of process complexity in their efforts to satisfy customers' demands and stay competitive. The BPM paradigm, which has successfully been applied in service industries, can help in managing end-to-end production processes, automating the execution of tasks by versatile agents, and providing an integral overview of the production status. With respect to the modeling side, BPMN is increasingly gaining attention in manufacturing to help in the analysis and design phase and the consequent execution phase of manufacturing processes. However, the notation has some inherent limitations that make it rigid to be applied in manufacturing. One of the main limitations is the fact that process instances, either of the same or different process definition, run in isolation, being agnostic of the status or information of peer instances. For example, process instance 2 is not aware of the status of process instance 4. The use of current BPMN elements such as messages and signals for interaction and collaboration among processes is limited, since they either target a single instance or they broadcast static information without any dynamic payload. The problem is more obvious in processes representing physical constructs, as I will explain in the next slides. So in manufacturing and logistics domain, buffering is a form of storage with the intention to synchronize flow material between production steps. From a single process instance perspective, a buffer point seems isolated and agnostic of what is happening outside of the instance's scope. From a process control perspective, we see the need of a controller to keep track and synchronize all instances. Similarly, the bundling construct is seen as the synchronization of instances that are grouped in some way, either virtually or physically, whose control flow shall continue or terminate simultaneously as a group. So the need for a central controller is solved with the notion of recipes. A recipe requires a set of input rules and produces a set of output rules. The rules can represent different instance types, each of them grouped in pools. For example, a recipe producing a red car gets as input the number and color of wheels, doors, and chassis. And each of the instances of a pool is a result of a process definition, typically independent of the instances of the same or different pools. So the recipe is then responsible to synchronize the information of all instances of all pools. To cover as many cases as possible, the recipe mechanism requires some configuration. Pools can be generic, meaning no selector attribute such as color is considered into the recipe fulfillment, or can be specific. Pools can be configured to account for physical availability of entities using availability masks, for instance, when only the first entity is available, in contrast to virtual pools where entities can be selected arbitrarily. Once the availability mask has denoted which instances are nominated for recipe fulfillment, the release policy dictates which instances to select. Finally, the fulfillment cardinality determines how many instances are needed for a pool to be considered fulfilled. The recipe mechanism is realized with the recipe controller process model as the central synchronization hub of various processes. So process modelers identify the synchronization points on the main process models and define and configure the desired recipes. We already propose a notation how to define these recipes. Focusing on the controller itself, and without getting into much details, the mechanism is based on common BPMN elements to handle messages from and to the main process models, and to evaluate and map the candidate pool instances to fulfill a recipe. The recipe synchronization mechanism was demonstrated in a real-world use case in the manufacturing printing domain within the European EIT Oedipus project. Here we saw a simplified animation of a process model, of the process models that represent the physical process of book printing production. We have a printer which prints books. Once the first book is printed, a command is sent to an automated guided vehicle to go pick up the books. So while the HGV is moving to the printer, more books are being printed. How many books have to be loaded on the HGV is dictated by a recipe, which can be based on production rules or the capacity of the HGV. So the process instances, let's say one instance per book, upon reaching the intended, the model synchronization points, generate information for the defined recipe. This recipe, for example, consists of books and HGV pools. So pools are being filled with process instances during runtime, and based on the recipe description, the release mechanism happens when the recipe is fulfilled. For instance, here, the recipe requires one HGV and 3 books. So when this happens, the mechanism will fulfill the recipe. And the process can move on. To conclude the presentation, we propose a solution to realize dynamic process synchronization and process instance correlation through a structured use of BPMN elements with the goal to support manufacturing constructs, more specifically buffering, bundling, and unbundling. The solution is innovative and ongoing research. Future work has already been identified to better configure the pools, for example, expressing cardinality in metrics instead of just units, or considering more physical characteristics such as stack orientation, or configuring recipes during runtime instead of just defining them only during design time. That concludes my presentation. Thank you for your attention, and I'm willing to answer any questions.
Thank you very much. And we're waiting for questions from the audience. Any questions?
Which we don't have yet.
Okay, so in the meantime, I want to clarify one thing. The recipe you talk about is the case. I mean, if we're asking about what's the case object of a process, is this the recipe? Or in your example, is this a book or a production order? What is the case?
Yes, the case, there is no specific, let's say, the recipe is the central notion to combine different process models. So for instance, here we have a process of printing a book, but the whole process, you can consider this as a case, involves much more process definitions. It involves the actual printing of the book, but also involves some transportation tasks, let's say, performed by this mobile robot. So the whole process of printing the book and transporting it and moving it to the next production step consists of different process models, and then the recipe is responsible to combine and synchronize information for all these process models and to correlate the instances of these process models.
Okay. Any other questions in the meantime? Andy, do you want to ask anything?
Yes. Well, it was a bit of a follow-up to your question, Nina. So thanks a lot for this presentation. I've seen already some presentations about the horse project before, I think a couple of years ago. So I think it's very interesting. And so maybe just a clarification question. So you're saying that the notion of case that you're having is somewhat split. So you're having certain objects that are running through your process, which are responsible only for synchronization, and other objects are somewhat objects related to the case, right? So probably the state of your process and something else. So this is something that is a bit unclear to me. And maybe just another question is, why don't you do synchronization using some, say, synchronization pool between multiple processes involved in your manufacturing scenario?
Yeah, well, the recipe indeed takes information coming from a process engine. It's not that it generates information. The mechanism is just a way to define the rules how to and when to synchronize the process models. So instead of leaving this quite arbitrarily, modelers can already define at which point when the synchronization should happen and which information is needed. The second question, what do you mean by using instead some pools?
Well, I mean a synchronization pool, so some shared storage, right?
Yes, we think that it can get quite complex in all the synchronization points. So having a quite more standardized or at least a notation how to define recipes, then it's maybe easier to adapt it or to, let's say, to do some analysis or to find out what can be some problems or where you need to change things, etc. So the mechanism is more a central controller, so we believe that it's better to to have it in one place.
Okay, maybe just a quick one. It's something maybe rather more philosophical. Why do you allow users to specify recipes?
Yes,
Why don't you allow the process actually to reason based on the task that you're giving to it? What to combine and when to synchronize?
Well, it's part of the process modeling. So the modelers themselves know when things should happen. So the modelers know that after the book is printed, an AGV should be there to pick up the book, then they understand that there should be a synchronization point. So it's part of their task during modeling.
Okay, so those are kind of rigid synchronization points that are by design already there.
Yes, it has to be, let's say, based on constraints or based, yes, on the process itself or the actual process, physical process itself.
Okay, thanks a lot. Thanks again for this presentation. So I think, again, yeah, we're out of time.
Yes, and we will turn to the last speaker, Fabrizio. Okay, so yeah, the last presentation is by a team of of people, and some of you have also seen the demo yesterday. So now it is related to that. It will be presented by Fabrizio Maggi. The paper is titled "Say It in Your Own Words: Defining Declarative Process Models Using Speech Recognition." So, Fabrizio, the floor is yours.
Thank you very much, Nina. Yes, as you correctly said, we showed the demo yesterday about this tool, and in the context of this presentation, we will show a little bit of user evaluation that we did about that tool. As you said, Pnina, this work is in collaboration with Han van der Raal from the University of Mannheim, and one of the students of mine at the University of Tartu, Karl Balder, and Alexander Nolter, that is a colleague also from University of Tartu. Most of you that are familiar with Declare know this picture is the typical picture to explain the difference between declarative and imperative process models, and then just for the novice in this field, in the imperative models you have to explicitly specify all the process executions. So if the process is very changeable and unpredictable, all these expressing all these exceptions explicitly would make the model cluttered, so difficult to understand. So what you do is to represent the same process using a hopefully small set of rules, so that in an open world, actually more behavior is allowed with a model that is more compact. Okay. So you actually just forbid, so you just allow all the behaviors that are not somehow limited by the constraints. So this is actually the typical expression that a person or a domain expert has when he or she looks at a declared constraint, which is the graphical representation in the first line of this slide, or even more if this person is not a theoretical person. Of course, also the LTL representation of the declare, which is the second line of this slide, becomes really difficult to understand for them. But in reality, what this strange, weird representations wants to state is actually that every activity A is eventually followed by an activity B, so nothing else than that. We started from this observation, and what we wanted to do was to allow declarative process modeling not anymore only based on the graphical notation of declare and on the formal representation of the declare rules, of the declare constraints, but also using the natural language as a bridge between the formal semantics of declare that is useful for checking and executing rules, and also the textual semantics of the constraints. In addition, this was a thesis that I supervised with this, in which I supervised the students Karl Balder, and in particular, the goal of the thesis was to even go further the idea of using the natural language, but even using speech recognition to somehow record a constraints and then translate it into a formal constraint. So what we did was to follow this approach, speech to RAM. RAM is actually a novel rule mining tool and that will be more deeply presented at ICPM, and International Conference of Process Mining. And what we wanted to do is to add a component to RAM for allowing people to model a process using speech recognition. So the input was a voice input, so from the user, and then this input is then translated into text, and this text is then interpreted for extracting constraints. So Han had developed an approach for mining constraints from text. So we used that approach and extended it in this context, as in context of modeling. So we take the text extracted from the speech recognition, and we extract the constraint using that approach. In addition, in this case, we don't use only control flow constraints as in the original approach, but we also give the possibility to the users to specify multiple perspectives in the context of these constraints. So to add data conditions over those constraints. So the difference is that while in the constraint generation, we actually use grammatical parsing to understand complex sentences. In the context of this work, for the interpretation of the conditions, we use pattern matching, because we assume that a text that represents a condition is a simpler sentence. And then we use this information, we put them together, and we create the declarative model that can be used, for example, inside RAM for supporting process analysis using process mining, for example. Together with this, with the speech recognition and the text recognition, there is also a graphical user interface that can be used for also adding manually constraints or edit the ones that have been added using the speech recognition. And again, you do the same. You can specify constraints manually. You add multi-perspective to them, and then you have the declare model at the end with using actually a standard editor. So the tool is there is a lot of material, tutorials and so on rulemining.org. So if you want to find also the demos, and if you missed the demo yesterday, you can find a screencast with the demo there. There is a screencast for the with the demo of RAM as well. So what we did in this paper was also to do a user evaluation to see if this ambitious experiment of actually modeling a process using speech recognition is actually feasible in practice. So we contacted 8 participants, and I would like to take this opportunity also to thank all the participants, because they gave a really deep feedback about the application. So if the application is now as it is, it's also thanks to their contribution, and we conducted this user evaluation via Skype with the facilitator supporting the user into performing an exercise, and an observer supporting the facilitator in the execution. So we gave, actually the exercise was very simple. We gave a test scenario with some information about the process, and then users had to actually use speech recognition to model that process using declarative rules. So it was a really standard modeling task. So for the data collection, we used follow-up interviews after the evaluation. We focused on the points that were critical for the users. Then we used the system. We used post-survey questionnaire and the system usability scale to check the usability in quantitative terms. And for the data analysis, we used the affinity diagram to collect all the suggestions and the notes given by the participants. We had quite a lot of notes, 129 notes, and 21 clusters collecting the notes by topic, and then of course the post questionnaires, and then we found the level of usability scale from the questionnaire. So the system usability scale was
Fabrizio, sorry, 1 minute.
Yes, I'm finishing. Was quite high in general. It's 73, and the user average is 68. The main thing was that in this using speech recognition in the context of process modeling requires a learning curve, because people actually have to understand how to interact with the application, because before using all the potential of that application. So there are other suggestions, like specific implementative suggestions, like modifying the recording or edit the text directly. And the main finding of this user evaluation was that actually this application is very usable in the context of mobile applications. So what we did at the end is to take this outcome of this user evaluation, and what we did was actually use this outcome in what you saw in the demo, and in particular one of the feature works that has already been implemented. Instead of using speech recognition, you can use in a desktop application, so not in a mobile environment, but in a desktop application, you can use a chatbot for inserting information using natural language, and then modeling the constraints in that way. On the other hand, we want also to go further in the direction of mobile environments in a way that we can actually see if in the context of mobile environments the modeling business process is still feasible. Of course, this can be done also in the context of procedural models, because there are also techniques for discovering the procedural models from natural language. So this is it. Sorry, it was a little bit long.
Thank you very much, Fabrizio. It was interesting, and I hope there are some questions. I see there's already a question here.
From Fernanda. Maybe I unmute and you ask yourself. Okay. Fernanda.
Perhaps you just read it.
Yes. Fernanda asked, she's guessing that the data analysis was also done via Skype. How did you conduct the affinity diagramming technique? What were the challenges?
Well, we actually recorded the interviews with people, and then we actually analyzed the recording, and then we extracted the affinity diagrams by playing the recording again and analyzing them in detail. So the interaction with the users was recorded. So we had the opportunity to go back to what the participants said during the user evaluation. So we could extract. Of course, it was quite also a long process to extract this information, and this was the thesis of the student, actually one of the tasks that he had.
Good. Does this answer, Fernanda? Is it okay?
Yeah, thank you. That was my question. Sorry, I couldn't unmute earlier, but yeah.
It's okay.
Thank you for the question.
Yeah. Any other questions? Okay. So just I have to ask you, because I saw it yesterday happening in the demo, and we all know that natural language is not as accurate as a model, and declare models are formal and accurate, and as a person, it's very easy to just use the wrong wording, and then you need to be able to see that the model is not what you intended it to be. So it's not that easy.
Yeah. So yeah, you are right. Yesterday, I forgot to say that one activity comes after the other, and I said that they should occur in the same process execution. So this was also one of the suggestions from the participants. So we really thank them for all these suggestions. And one suggestion was to have some predefined descriptions of the constraints in a way that when you record the constraints, then you see the representation of the model using the standard declare notation, but then you can switch the representation of the same constraints using also the automaton view, but also a predefined description of the constraints. So you can actually check if that predefined description of the constraints is actually in line with what you said. Another addition that probably it could help also in explaining what is the semantics that was understood from the tool. It's to give somehow examples and counterexamples of traces that satisfy and violate the constraint in a way that the user can actually figure out better if the semantics is exactly what he or she meant.
Yeah, it sounds like a good answer. Do we have any more questions from the audience?
Not really.
Okay.
So
yeah, we have a question here from Hugo. Yeah, please unmute yourself.
Hi, hey again.
Hi.
Regarding to your last answer, I wonder whether there could be some feedback from learning from users, because one thing is to fix your interpretation of what the user says, another to learn from it. I could tell you that a shall should be mapped as a response, but some other user would say, well, a shall should be a combination of a response and a condition between these two different events. Would it be possible to actually apply some sort of a reinforcement learning in order to learn from that?
Yes, I don't know if you look at the demo yesterday, and actually you see that that there is actually a basic chatbot that we developed based on the outcome that we got from the user evaluation. So maybe the reinforcement learning could be actually be included when by making this chatbot a little bit more let's say sophisticated. So because now it's a very basic chatbot, so it asks very simple questions, and then for that interaction with the user, so the chatbot can be the starting point to have an interaction with the user, and then from these interactions actually to use a sort of reinforcement learning, and then identify patterns in these interactions, so that the interaction with the users could also improve the understanding of the tool itself. I don't know if this answer.
Yeah, but I'm thinking much more from not at the level of understanding of natural language, but from the mapping of your, for instance, of your words, for instance, shall or conditions or the like, into a formal representation. At least in our work with the process highlighter, we have seen that certain words, I give it to a lawyer, and he would define, he would represent that with a given set of constraints, and other person would make other use of constraints.
Yeah, to contextualize the type of expressions.
Yeah, I mean, it's also related to the paper that Amin presented today on the quality of the clarity process models. So we want process models that are as flexible as possible when we look at the CLAIRE DCR graphs. But then a novice user would really put a lot of constraints, whereas a more expert user would use less amount of constraints for the same annotation. And the question there would be whether we could actually learn from that to really to decrease the amount of constraints or have a better mapping.
Yeah, I think that's an extremely good idea, in the sense that you can actually use this information to somehow simplify the model, and I think that also I'm not sure if in the work of Han, in the extraction of constraints from text, actually there is the possibility of extracting a set of constraints there, right? And I think from the text, if you extract different constraints, you can somehow improve that model by minimizing, of course, the number of constraints, because, as I said, the compactness of the model is extremely important in the understandability. I don't think anything has been done up to now, but yes, if you have some hints and some information about how to do it in your paper, maybe you can send this paper to me, and
I think this is an area we could collaborate. It's really, and we have data, so we can definitely.
Guys, let's take this offline.
Okay.
Now it's time for coffee with the authors.
Okay.
So before the next panel, so I just wanted again to thank all the speakers in this session, which was
Thank
a
you.
great session, and yeah, thank you.
Thanks.
Thank you.
Thanks, everyone.
Bye.
Thanks.
Bye.
Bye-bye.
Bye.